Okay, welcome back. And so, this is going to be our first example here. So, just to give you an idea of what we're talking about some of those definitions that we went through. So, for example, this first one, 3x1 plus 2x2, this would be an example of a linear combination. Okay, these other two are not. These are not linear. So notice here that on the x1 there's an exponent of 2. So on a linear combination, all of the exponents on all of the variables has to be 1. Okay. Also, this is also not a linear combination because we have a trigonometric function here. Okay. So that is not linear. Okay. So again, when we talk about linear combinations, we're talking about a sum of products where the variables have an exponent of 1, okay, and they're not dealing with any kind of trig functions or anything like that, okay. Now, a couple of things to note is we typically, when we write a linear combination and hence a linear equation, we're assuming that all of the coefficients are unequal. And the reason why that is because if there were coefficients that were the variables. We're assuming the variables are unequal. Because in the case that if the variables were the same, we can just combine them and move on. So when we're dealing with the abstract and we have x1, x2, x3, we're assuming we're pretty much mostly assuming that they're unequal values. Okay, so because, for example, in this one here, we could just combine these to simplify it, right? So we can combine these to simplify this equation, right? So in this case here, we've got 6x over here, and we've got a 6x over here. So again, we could combine those, and we would get 0x, right? Plus, and then we have 3y over 3y, which again gives us 0y, right? So it ends up canceling each other out. But here, the main thing is we can take this and simplify it to this. Okay? Now, the other thing too is sometimes, and again, it just depends on the situation, as far as convenience goes, but sometimes we'll add a term that has a 0 coefficient. Okay? Sometimes we'll omit it. It just depends on what we're doing. Okay? So just keep that in mind.